Yeah, so hello everyone. So today let us try to discuss one very important concept called parallel plate capacitors. So I have taken up some models over here. So through which I try to explain the concepts very clearly to you. Okay. So let us start with the basics over here. So I am just going to teach one or two points which I am going to use in the problem solving, okay, or analyzing the situations that I have taken. So let's say there is a like parallel plate capacitor which is formed because of two conductors, I can say, or like two parallel plates. Okay, so two conductors. Let's say this is conductor 1 and this is conductor 2. Now for a parallel plate capacitor, like I guess you know the formulas. So capacitance, you guys will be using the formula A epsilon naught by what? D. So where A is the area of the cross section area of the plates and epsilon naught is the permittivity of free space and D is the distance between them, right? And one more formula that you guys will be using is what? Q equal to CV. But here I wanted to emphasize more on this formula. Okay, so like in this formula, so in general you'll just write the value Q equal to CV and everyone will remember this formula, but I want you to like have more clarity on what is Q over here and what is V over here. C is obviously the capacitance of the like whatever the capacitor that you take, and the Q over here is charge on the very important charge on the inner surface of the higher potential plate. So this is very important. Okay, so just by remembering this formula you won't be able to tackle some good questions. So don't think that Q equal to CV means simply it's a charge on the capacitor, it's the charge of this conductor, left side conductor, or like whatever the higher potential conductor is there. No, it should be what? Charge on the inner surface of the what? Higher potential plate. Higher potential plate means the plate which is connected to what? Higher potential, relatively higher potential. So then, sir, what about V? V is the potential difference between the plates. V is the potential difference between the plates. V is the potential difference. Okay, not simply we'll write it as V, but actually you guys need to understand here V means what? Actually it should be written as delta V, but just to write it in shortcut we'll be just writing it as what? CV, but actually it should be what? C delta V, where delta V is the potential difference between the two plates that we have considered. Okay, so that we understood. That means actually speaking, so here we should write it as Q and here we should write it as what? Minus Q. So this is how the representation is. And let's say the potential difference, this is obviously this should be what? Higher potential. This should be like what? Higher potential, and this should be what? Lower potential. Then only I can tell that the positive charge will be there for like what? Inner surface of the higher potential plate, and negative charge will be there for what? Negative charge will be there for like inner surface of the lower potential plate. Sir, how can you tell that these two will be equal always? How we can tell means, see, I can consider a Gaussian surface over here. We know that it's a conductor. As it is a conductor, we know electric field inside a what? Electric field inside a conductor is what? Zero. So these are what? These are conductors. So conductors means we know field inside conductor to be what? Zero. Field inside is what? Field inside is zero. So if field inside is zero, then I can consider that here electric field lines will be like this. So sorry, means outside. So here anyway E bar dot ds bar will be 0, and here electric field won't be there inside the conductor, so there is no flux. Okay, E bar dot ds bar, there is no electric field, so there is no flux. No flux means Q inside should be 0 according to Gauss law. So for the Q inside to be 0, let's say here if Q is there, for sure here what charge should be there? Minus Q. Okay, so here for a capacitor on a like one plate, if you have a Q charge, obviously on the other charge, what on other plate what charge should be there? Minus Q. Okay, but depending on the situation, remember like here and here any charges can be there. Depending on situation, here and here any charges can be there. But here I want to emphasize on one more thing. Any charges means there is one more relation between Q1 and Q2. What is that relation? Let us try to derive now. So what is the relation means? See, try to understand here. The relation here is If I consider again Gaussian surface over here, so this is the charge distribution I have given, right? So this is the charge distribution that I was telling. What's the charge distribution that I was telling? Here Q and here minus Q, that is fine. Why it should be equal and opposite, that we understood. Let's say here Q1 is there, here Q2 is there. So as I said, there is one more relation between Q1 and Q2. Let us see what is that relation between Q1 and Q2. Okay, sir, let us try to understand that. What is that relation means? Let me consider field over point A to be 0 because it's inside the conductor. So you know, already I told inside the conductor field to be what? 0. So electric field at A should be what? 0. So you can see that there are total how many plates that are there? 4 plates. You need to understand this charge is entirely distributed on what? This plate. Okay, writing Q over here means this Q is distributed over this entire plate. Q1 is distributed over this entire plate. Okay, sir, this is fine. Now, as I said, when we want to write electric field at A to be 0, already this Q will try to apply the electric field in what direction? Left side. And this minus Q will try to apply field in what direction? Right side. So field due to Q and minus Q over here will become 0. Field due to this Q plate and this minus Q plate, here it will become what? 0. And one more important thing you guys know, field due to infinite plate is independent of what? Distance. Okay, field due to infinite plate is what? Independent of distance. That means field due to this and field due to this, here irrespective of the distance, you guys know the formula, it should be what? Q by 2a epsilon naught, right? So that means for the net field to be 0 implies field due to this Q1 plate must be equal to field due to this Q2 plate, which is nothing but Q1 by 2a epsilon naught equal to Q2 by 2a epsilon naught. That means here we got one more important result, that is therefore Q1 equal to Q2. That means on the outermost plates, the charge must remains what? Same. On the outermost plate, the charge must remains what? Same. This is one more important conclusion that we have derived. Okay, so here you might be thinking or like asking a doubt yourself that, sir, why you consider it as an infinite plate? I can see it is a finite size. Okay, you need to understand, compared to the distance between the plates, the area and the length, the area of the plates will be like what? So huge. Okay, that's why we'll consider it as like what? Field due to infinite plate. Okay, so I'll just give one very important simple example so that you guys can connect. So let's say, imagine this pen. Okay, this pen might not be a infinite thing for you, but imagine there is an atom. Okay, there is an atom. Imagine it's like atom is a person now. So for atom, obviously this seems like an what? Infinite thing, right? So it depends on the relative term, right? So let's say there is a mountain, there is a big mountain. Okay, or let's say there is a Mount Everest. When you see from top of a plane, then you'll be able to see the complete Mount Everest, right? So you'll be able to see the Mount Everest, and you will be because of your the visual angle and all, so you'll be just able to see, so this much the Mount Everest I can see is just fitting inside my fingers. You'll be able to tell like that, right? So imagine that you're just going to go nearby the Mount Everest and stand beside that, and you can't even see how much big it is, right? So that means the infinite here means, okay, the size might not be infinite, but compared to this relatively the size can become infinite. What does that mean, sir? Means if there is a plate, this might be a finite length. Okay, for if I consider a point if I consider a point over here, then this plate is a finite plate. But imagine I'm taking a point which is so close to this. So close means infinitesimally close. Then for that point, okay, so this length will appear to be what? Infinite. So that's why you can see when you solve the numericals, the value of d, you will see it in what? Micrometers and all, right? So and the area will be in meter square and all that stuff. So that means, so you guys can able to use these formulas only for what? Infinite plates. Then why, sir, these are finites? Why are we using this formula? As I said, as the distance between the plates is so less, okay, so these points, for this point I can consider this place to be what? This plate to be infinite. So that's what is happening. So one more important point that I proved, irrespective of the distribution, here and here the charges must be equal, then only the field inside the conductor will be 0. And one more important point that we have proved, inside the conductor the charges should be what? Equal and opposite signs. And we also understood what is the, in the formula Q equal to CV, what is the charge q, that we understood, and not only that, we also understood what is the v over there. V is nothing but what? Potential difference, right? Clear? So now with these basics, let us try to jump into solving some standard models over here. So in this question, see here they're telling area of each plate is A. The conducting plates are connected to a capacitor of EMF V volts. Then they're asking what is the Q1 and Q6. If you can see here, they haven't mentioned anything about the initial charges on these plates, right? That means simply you need to consider that there is no initial charges on any plate. Okay, there is no charge on any of these plates, so that means the total charge should be 0. So now, as I already told the capacitor properties, imagine here q charge is there, or let's say this is C1 capacitance, this is C2 capacitance, total two capacitors are there. So imagine that here the charge is like what? Here the charge to be q1, then automatically here the charge will be what? Minus q1. And imagine the charge over here to be what? See why I have taken positive over here, this you guys need to understand. So you can see that lower potential is connected to this plate, higher potential is connected to this plate. That's why I have taken positive charge over here, negative charge over here. Then so similarly here you guys need to understand, here q2 will be there because the positive higher potential is connected to this, lower potential is connected to this. So here what will be there? Minus q2 will be there, minus q2 will be there. So if you see the total charge over here and total charge over here will be what? 0. That means now charge over here plus charge over here must be what? Total sum is 0, right? Originally they haven't given any charge to these plates. Now let's say charge over here is what? Q1, charge over here is what? Q2. Now I can write two equations over here. What are the two equations that I can write? As I said, one thing is Q1 plus Q2 must be equal to 0. Sir, how we got this? From charge conservation. Because initially there is no charge that is given, so because of charge conservation, so finally also the total charge on the system must be what? 0. The charge can redistribute, but charge cannot be created nor destroyed, right? So it can be just redistributed between these plates based on how the connections are done. So that means q1 plus q2 must be 0. But already I have derived one more important point over here. So for the field to be 0 or here or here or here, obviously field due to these things will be 0 anywhere inside the conductor. So remaining two plates are what? Remaining two surfaces are this q1 surface and q2 surface. For the field, net field inside the conductor to be 0, so here one more condition should be possible, that is q1 must be equal to what? Q2. Sir, why? Because for the field to be what? For the field to be 0 inside the conductor. For E equal to 0 inside the conductor. Inside the what? Conductor. So this should be the condition. Okay, sir, this one also understood. When sum is 0 and both are equal, so that means what is the conclusion? Therefore, both Q1 and my bad. So this they have given a name as what? Q6, right? So it is on the 6th plate. So this is Q6. Let me just change the names. So this is Q6. So therefore Q1 plus Q6 is 0. Q1 equal to Q6. So therefore Q1 equal to Q6 equal to what? 0. So this will be the answer. Okay. Let's say for suppose they are asking you to find what is the charge, let's say Q2. Okay, Q2 is nothing but what? Q1, or else let's say they are asking you to find what is the charge Q5 or Q4, whatever it is. Let us try to analyze that situation as well. So first let me write C1. C1 is nothing but what? A epsilon naught by what? D. So where C1 is this capacitor. And similarly let me write C2. C2 is nothing but what? A epsilon naught by what? 2D. Right. So I got the value of C1 and C2. Now I can write the value of Q1. Our Q1 is nothing but what? Our Q1 is nothing but Q2. So Q1 is nothing but what? C1 into delta V. Sir, what is C1? C1 is nothing but A epsilon naught by D into delta V is nothing but what? Potential difference between these 2 points. So already it's connected to a potential difference battery of V, right? So therefore this will be the value of Q2. So I got the value of Q2. Then Q3 is nothing but what? Minus Q2 only. If this is Q2, this will be what? Minus Q2. Q3 is nothing but minus Q2. And let's say this is Q5 and Q4 is nothing but what? Minus Q5. So like this I can I was able to find all the charges. As I said, Q5 equal to what? Q5 is nothing but what? So not Q5, second capacitor, so I have taken it as what? Capital Q2, and our capital Q2, the charge on the second capacitor is nothing but what? Capital Q2 is nothing but Q5, that's what they are naming it as. Q5 is nothing but what? C2 times delta V, which is nothing but A epsilon naught divided by 2D multiplied by V. So these are the charges what? So Q1 I got, Q6 I got, Q2 I got, Q5 I got. Sir, what is Q3? Q3 is nothing but minus Q2. Sir, what is Q4? Q4 is nothing but minus Q5. So like this, you'll be able to find all the charge distributions, right? So I hope it is clear for everyone. So let us move to the next question. So in this question they are telling three identical metal plates are kept parallel to one another at a separation of what? A and B. There are two separations and connected by a thin conducting wire. So when they connected by a thin wire, that means you need to understand both will have a same potential. Let me name it as V1 potential. Let me name it as V2 potential. Okay, sorry, it will be same potential, right? V1 itself. And let me name the center one as some different potential V2. Okay, and let me name this capacitance as C1, let me name this capacitance as what? C2. Two capacitors are there because of these three plates. Now they are asking find the final charges on all the 6 plates. So that initially they haven't given any charges. Again, that's a note point because they haven't mentioned anything, right? Initially they haven't given any charges over here. So then see, first of all you need to understand that. Okay, so here I'll tell one more important note point. Okay, if you want, you guys can derive it. It's like very easy. By writing the equations you can derive irrespective of number of plates that are there. Irrespective of number of plates that are there, let's say initially there is so this one is given some Q1 charge, this one is given Q2 charge, this one is given Q3 charge initially. So after, okay, so like immediately because of this capacitive nature and all that stuff, so the final charge distribution, okay, the final charge distribution will be something like this. So how the final charge distribution will be there? You guys need to understand the complete mean, okay, the mean of these capacitors. So the mean of these charges will go on to the either sides. That means here Q1 plus Q2 plus Q3 by 2 it will be, and similarly here also Q1 plus Q2 plus Q3 by 2. So this will be the final charge distribution. Once you get the charge over here and here, it's like done, everything is done. Sir, what everything is done? Let me name this as some small q charge. Let me name this as small q charge. Already I know the charge on this plate, right? And you can see that this plate is not connected to any other plates. That means charge must be what? Conserved over this one. So if q charge is over here, that means inside the charge should be obviously what? Q capital. Initially it's Q1 is there, so Q1 minus Q. And what about the charge over here? Charge over here should be what? Q3 is there, out of that Q is outside, that means here Q3 minus Q. And here when some X charge is there, here what charge should be there? Minus X. Here when X charge is there, obviously here what charge should be there? Minus X. Right? So I hope it is clear for everyone. So this is how the charge will be distributed. Okay, it's very very important. So now I am just going to use that concept over here, as initially no charges are given to this plate. So that means what is the mean charge? Mean charge will be what? 0. That means automatically here 0 charge will be there, here 0 charge will be there. So no need of bothering about that. Now let's say here I am considering that V1 to be higher potential and V2 to be what? Lower potential. So you need to understand that as delta V1, okay, delta V for both the capacitors are same. What is the potential difference for between these two plates? V1 minus V2. And what is the potential difference between these two plates? Again, see, this plate is connected to V1, this plate is connected to V2. Okay, that means both the capacitors are connected and what? Both capacitors are in both capacitors are in parallel. Both capacitors are in what? Parallel. And consider, okay, I am considering what? I am considering, consider V1 is more than what? V2. I am just considering if V1 is more than V2, what I can tell? So I can tell, let's say here, so as I said, for the higher potential plate you will be having positive charge. Let's say here Q is there, then here automatically Q1 is there, here automatically what will be there? Minus Q1, right? And similarly here when let's say higher potential is Q1, so here Q2 is there, here automatically what will be there? Minus Q2 will be there, minus Q2 will be there, right? So now as I said, these two are connected in parallel. The potential difference must be what? Potential difference must be same. So I know the formulas for the charge, q1 is nothing but what, c1 delta v1, okay, potential difference for the first case, and q2 is nothing but what, c2 delta v2. Okay, if you're getting confused, let me name it as va and vb. So let's say va is more than vb. So this is delta v1 is the potential difference for the first plate, delta v2 is the potential difference for the second plate. But for both the plates, delta v is nothing but what, va minus vb. So now what I am doing, let me just divide these two. Okay, by dividing these two, therefore what will I get, q1 by q2, what I will be getting from here, q1 by q2, I will be getting it as c1 by c2. But already I know c is nothing but what, a epsilon naught by d. So they told identical plates, so they'll have same area, a epsilon naught by d. What is the distance between the first capacitor, distance between the plates for the first capacitor, a, into for the next one you will be getting b by a epsilon naught. So therefore what's the value of q1 by q2 I am getting, q1 by q2 I am getting it as what, b by a. q1 by q2 I am getting it as b by a. So let us keep it aside. So this is one equation that we got. Now the next important thing over here is, let me discuss over here. The next important thing is, you can see that this is isolated. Whatever this capacitor, isolated means not connected to anything. This is what, isolated plate. Sir, isolated plate means what will happen, charge on that must be what, charge on that plate must be conserved. So that means originally, as no one has given any charge for that plate, so that means total charge on that should be what, 0. And finally if you see what charge is there on that plate, so on that plate we are having minus q1 minus q2, which should be equal to what, 0. So that means therefore q1 plus q2 must be equal to what, q1 plus q2 must be equal to 0, because minus I have sent it other side, so it will be q1 plus q2 equal to 0. But from here I can write, let's say q1, I will write it as, from here what we can write, q1 plus q2 I can write it as q1 into what, a by b, q1 into a by b, which is equal to what, 0, So from here, what's the value of charge I will be getting from here? There's no charge. Did they give any charge? Okay, my bad. So here they are telling that it's isolated plate, so charge should be conserved. So here they are telling that the outer plates are connected by wire and the charge q is placed on the center plate. That means for the center plate they have given a q charge. So charge should be conserved, that's fine. But that minus q1, this whatever the charge that is there, okay, minus q1 and minus q2, so this charge should be what, conserved. That means minus q1 minus q2 sum together must be equal to whatever the charge that they have given. That means that implies q1 plus q2 must be equal to what, minus q. Sir, what about how to find this q1 and q2? Once I find the q1 and q2, I can tell what is the charge on each plate, right? So how to find this? Let me eliminate q2 and write it as what? q2 can be written as what? q1 into a by b, which is nothing but what? Minus q. So from here if I take q1 common, what will be left out with? a plus b by b, which is nothing but into minus q, which is equal to minus q. So therefore q1 equal to what, sir? q1 equal to minus qb by a plus b. So this is the value of q1 charge. This is the value of what? q1 charge. If this is the value of q1 charge, so therefore similarly q2 charge will be equal to what? q2 is nothing but what? q1 into a by b. So if we just multiply it by a by b, I will be getting qa by what? qa by a plus b. So this is the charge charge value of what? q2. Once I find the value of q1 and q2, so everything is done, right? q1, what is the charge on the first surface? 0. Charge on the second surface is what? q1. Charge on the second surface, third surface is what? Minus q1. Charge on the fourth surface is what? Minus q2. Okay, so I hope this concept is also pretty much clear for you. So it's like a standard one. So many times they have given in mains and bit-set exams. Okay, so these type of parallel plate conductors where initially charges are given, okay, and two conductors are connected, or like connected by some like external battery, or like shorting, or like connecting to the earth. So all these type of things, right? So I hope it is clear for everyone. And this is one more important model. So and recently in like 2024 advanced paper 1, they have given an what matrix matching question based on this. Okay, so I have done a video on that. If you want, you can go and check that. So it's like like you need to know the like approach for this. Okay, only then these type of questions will be easy for you. Otherwise, if you're just like randomly trying to analyze the situation, it will be very difficult for you to know which one will be parallel, how like which two capacitors are in parallel, which two capacitors in series. It will be very difficult for you to analyze. Okay, so in that video very clearly I explain the entire concept. So again here I just wanted to like briefly explain how to solve these type of questions. Okay, so you need to ensure that like each and every plate should be given some name. That means should be given some potential. So already this is given some A potential, this is given some B potential. So if this is B potential and these two are shorted, you need to understand that this plate will also have name what? B. Why? Because these two plates are shorted. So if this is given name as B, and this will also be having a name as what? B. Okay, now so this plate doesn't have any name, right? I'm giving a name for this plate. Let me give name as what? C. Let me give name as C for this plate. Okay sir, fine. If this is C plate and now this is shorted with this plate, right? That means this plate should be given a name, one more name, what? C. Now let us check each and every plate. Does each and every plate got a name? This is C, okay. A, okay. This one is having name as what? B, okay. But this plate doesn't have any name, right? I'm giving one more name for this capacitor, sorry, this plate as D. Okay sir, fine. This is D and this is C because it is connected to this plate, and this is B. Okay, so this got name as B because this is shorted with what? This plate, whatever that is there. Now total how many potentials are there in this given circuit? So total 4 potentials are there. Ensure that you will just draw the 4 potentials. Okay, and the extreme ones should be between the extreme pair should be like what? Extreme point should be the points between which you need to find the equivalent capacitance, or the same thing will be followed by the resistors as well. So then this is A and this is what? B, and in between I am just keeping C and what? D. So total how many capacitors are there? 1, 2, 3, 4, 5. You need to ensure that total how many capacitors are there, sir? Total 5 capacitors. You guys need to ensure that all 5 capacitors are placed in this circuit. Okay, so the first capacitor is between like which two points, which two potentials? A and C. So I am placing that first capacitor is between what? A and C. Fine, one capacitor is done. And you need to understand that all the capacitors are equal because all the plates have same area, and the distance between the any two plates is also what? D. So all the capacitors are what? Same. So then between A and C I place the first capacitor, and next capacitor is between what? Like which two points? A and B. So A and B means the first point and the last point, like this, right? So the second capacitor is between A and B. Yes sir, I have connected. So the next capacitor is between what? B and D. Third capacitor is between what? B and D. So I have connected one more capacitor between B and D. So this is also fine. And next capacitor is between what? C and D. So next capacitor is between C and D. So I have connected one more capacitor between C and D. And the final capacitor is between what? You can see that it's nothing but B and C. Final capacitor is between what? B and C. So I'm just keeping one more capacitor here between B and C. So you can see that the circuit has turned into a like what? Simple thing, right? So you can clearly see that how these two are connected. These two are connected in series, and that one is in parallel with this one, and the result is series with this one, and that the resultant one is again parallel with what? This one, right? So it's like pretty much over. After representing the points and just rearranging the given circuit, it's completely done. C, 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 right? So this C and C in series, how much you are going to get? C by 2, and that C by 2 and this C is in what? That C by 2 and this C is in parallel. So C by 2 and C in parallel, how much you will be getting? 3C by 2, right? So let me just name it as stepwise. So this whatever this entire thing is there, this will become what? C by 2, and that C by 2 C in parallel, so you'll get 3C by 2. So So I'm just rearranging the circuit again. So 3C by 2. So here I got C, and here what is the equivalent I got? 3C by 2, and here what is there? C is there. So this is the thing after I got. After like what, simplifying this is what we have got, and this point is nothing but what? C. Between C and B already I have simplified the circuit. Now these two are connected in what? These two are connected in, okay, again C means you will be confused with the capacitance. Yeah, so these two are connected in what? Series. So connected in series, so simply C equivalent, so final C equivalent will be equal to what? C equivalent is nothing but these two are connected in series, and with this C is there as parallel. So C plus, that means this plus, what will be the equivalent capacitance for this one? Two things are connected in series, C1 C2 by C1 plus C2, right? C into 3C by 2, 3 into 3C by 2 by 3 into 3C by 2 by C plus 3C by 2. So which means like obviously one C will get cancelled, so it will be 1 plus 3 by 2 is what? 5 by 2. So it will be like what? C plus 3C by 3C by 3 will get cancelled, 3C by 5 only, right? Yeah, so it will be 1 plus 3 by 2, which is nothing but what? 5 by 2, 2 will get cancelled, so 3 by 5, 3C by 5. So therefore C equivalent is nothing but what? C equivalent is nothing but 8C by 5. So this is the equivalent capacitance between A and B. And as they haven't given the value of C, if you want you can just write it as what? 8A epsilon naught by 5D will be the answer. Okay, so I hope this model is pretty much clear for you. So there is nothing in this question, you just need to give name for each and every plate. If they are shorted, okay, then you just give the same name. If they are grounded, then give the zero potential, grounded earth, and then try to rearrange the circuit. Then you are going to get simple circuit. Either you will be getting simple connections like what? Series parallel simple combinations, or else in some good questions you might get some Wheatstone bridge or symmetry or like some mirror image kind of circuit or like whatever it is, and from there you just need to use the like what, circuit minimizing techniques, and you can solve the like given situation, right? So I hope that is also clear for you. And so let us see in this question. So here they are telling there are 4 plates, and you can see that they have given the charges now. Okay, so already I told a concept over here, right? Earlier I have told this concept, how the charges will be distributed. Now you guys can easily, okay, solve this question, right? After knowing that concept, you guys can easily solve this. Okay, sir, how? So here they are asking surface having charges of same magnitude and sign, surface having positive charges, uncharged surfaces, that means no charge, charged surfaces, all these things they are asking, right? So first let me find the Q. Q is nothing but what? Q mean, right? Q mean is nothing but what? Sum, total sum, 4Q plus 2Q plus 7Q whole divided by how much? 2. Mean only, right? So mean, so not mean basically, so mean means again you will be dividing with 4, right? Not 4, it's like total sum divided by 2, so that will be the answer, right? So 4Q, Q, 2Q, 7Q, what will be the value then? So it will be 9 plus 1 10, so therefore Q equal to what? 7Q. Therefore what is the value of Q I got? Q I got it as 7Q. So then once you got the value of Q as 7Q, then I hope it's done, right? So here it will be 7Q, and here it will be what? 7Q. Once here we have 7Q, here what will be there? The total charge on this one, all the plates are isolated, right? All the plates are isolated. Okay, then here as 7Q is there. Okay, once again I am telling, like it's not average, okay, it's like simply total sum of all the charges divided by what? 2. So then here 7Q is there, so this plate should have 7Q, so automatically here 0 should be there. When charge on the inner surface is 0 for one plate, automatically for this plate also it should be what? 0. Okay sir, and total charge should be 2Q, so here it should be what? 2Q, and when 2Q is over there, here how much should be there? Minus 2Q, but this plate should have how much? This plate should have Q charge, so automatically here how much charge should be there? 3Q charge should be there, and when 3Q is there, automatically here how much charge should be there? Minus 3Q, and now you can check back this 7Q and minus 3Q will get it as what? 4Q. So that's it, total charge distribution is done, right? So now they're asking surfaces having charges of same magnitude and same sign. So same magnitude and same sign. Which surfaces? You can tell 1 and 8, right? So same magnitude and same sign, right? So the first answer is what? 1 and 8. Fine, understood, right? And the second question, what they're asking, surfaces having positive charges. Which surfaces are having positive charges? 1, 3, 1, 3, 5, 8. 1, 3, 5, 8, right? 1, yeah, 1, 3, 5, 8. So 1, 3, 5, 8. So for this one, you can tell this one 1 and 8 and 3 and 5. Surface having positive charge. 1 and 3 and 5 are also having, 1 and 8 are also having. But 2 is having what? Negative charge. 3 is also having negative charge. 6 is also having 0 charge. 6 and 7 are having 0 charge. Uncharged. Uncharged means 0 charge. So you need to give for this one, right? Charged surfaces, right? Which are charged surfaces? Basically all are charged surfaces. That means for this one, you guys can give this one and this one. So basically all the plates are charged except what? Except this 6 plate and 6 surface and 7 surfaces. Okay, 6 surface and 7 surfaces are not charged, so they are having 0 charge. Okay, so I hope this concept is also very clear for you. So it's complete just based on the note point that I have already discussed, right? Fine. And again, let us come to these two questions from HC Verma. So in this question they are telling which are having each plate is having some area is given, on one side separation is given, so EMF connected to the battery is so and so. Now find the magnitude of charge supplied by the battery to the each capacitor connected to it. Okay, so I am not going to solve this with the numericals. Okay, I'll just consider it as some variables over here. I'll try to derive. So let's say this is V potential. Okay, let's say this is V potential and all the capacitance are same. Let's say C. Okay, so this V is given, this C we can find by using the formula A epsilon naught by D. D is given, area is given, so that's all, it's fine. Okay, so with these variables I'll try to find. So here what they're asking, find the magnitude of charge supplied by the battery to the each plate. Okay, so they're asking what is the charge supplied by the battery to each plates connected to it. So they're asking what charge is supplied to this each plate. So obviously initially there is no charge that is given, right? So when there is no charge that is given, that means charge on each plate earlier is 0 and final charge on all the plates should also be what? 0. But now whatever the distribution that can take place, obviously the distribution can be like what? How the distribution can take place? Through battery, some charge can either flow from here to here or from here to here. But the charge cannot jump from this plate to this plate or this plate to this plate or this plate to this plate or this plate to this plate. Charge can flow only when there is a connection, either through a battery or either through a connecting wire like this. That means charge can play a game between these two plates or charge can play a game between these two plates. Okay, I hope that is clear. But charge cannot flow from this plate to this plate and charge cannot flow from this plate to this plate. And one thing you guys can clearly tell over here, charge over here will be 0 and charge over here will be 0 because no initial charge is given, and sum of all the charges by 2 will be the charge on what? Either side of these extremes. Okay, fine. So that is fine. Now let us try to rearrange. Okay, so let me consider this potential to be what? 0, and let me consider, or let me give name for this. Yeah, we'll do one thing. Let me take this as 0 potential and this as V potential, and let me take this as what? V dash, and let me take this one as also what? V dash. Now total how many points are there? 3 points are there, right? So what are the 3 points? 1, 2, 3. So that is V, 0, and in between one more point is there, V dash. And the first capacitor is between what? What 2 points? V and V dash, right? So I am keeping that capacitor here between V and V dash. This is one capacitor, and the second capacitor is between which 2 plates? V dash and what? V dash and 0, right? V dash and 0 potential. So V dash and 0 potential, that's also done. And the final capacitor, this capacitor is also between which 2 which 2 plates? 0 potential plate and V dash potential plate. So that means this is how the circuit is there, right? This is the circuit. That means here this is C, this is C, this is C. Yeah, so all these things are like what? C. Now they are asking us to find what is the charge on and you need to understand to differentiate. Let me call this as first capacitor, this is second capacitor, and this is third capacitor. This is our first capacitor and this is our, let's say, second capacitor, and this is, let's say, our what, third capacitor. So we have 1 2 3 capacitors over here, right? So now so basically I can find the total charge, right? First of all, because I know the potential difference, I don't know V dash. Okay, you might be thinking that, sir, I can directly find the capacitor on this potential. No, because you don't know the V dash potential. Sir, I can find the like charge on this plate directly. No, you don't know the V dash. Okay, until you know the value of V dash, you cannot find potential on any, so you cannot find charge on any capacitor. Why? Because for this capacitor, what is the potential difference? V minus V dash. For this capacitor, what is the potential difference? V dash minus 0. For this capacitor, what is the potential difference? V dash minus 0. Right? So obviously you guys cannot tell the value of the charges on each capacitor unless and until you know the value of V dash. So here I am just going to tell how to find that V dash value. So you can clearly see that these two, how they are connected. How they are connected? They are connected in parallel, right? So as they are connected in parallel, so obviously the circuit will be something like this is V potential, this is 0 potential, and this is what, V dash potential. But this is C capacitance and this is what, C by 2 capacitance. Now you can see that both are connected in what, series connection, right? This is what, series connection. Series connection implies what does series connection implies? Series connection implies that same charge. Series connection implies same charge, right? Same charge. That means for the same charge to flow, so obviously C delta V should be same. Let me consider this is here, so therefore same charge, so Q equal to C, okay, charge on each capacitor, Q equal to C delta V1, which is equal to C by 2, sorry, why C by 2? They are in parallel, right? Parallel means for capacitor what will you do? We'll just add them. So C and C, it will be what? 2C. C and C, it will be what? 2C. Yeah. So C delta V1 and 2C into what? Delta V2. So therefore C into delta V1 is nothing but what? V minus V dash, and 2C into delta V2 is nothing but what? V dash minus 0. So therefore CC will get cancelled. So V minus V dash equal to what? 2V dash. So therefore V dash equal to what? V dash equal to V by 3. Once we get the value of V dash, so like we can find charge on any given capacitor and any given plate. So it's very simple for us, right? Once we get the value of V dash, potential difference between these two plates is nothing but what? V minus V dash, which is nothing but 2V by 3. Between these two is like what? V dash and V, right? V dash and 0, right? So it's V by 3. Between these two plates it's V by 3. Between these two plates it's V by 3. Between these two plates it will be 2V by 3. Once you get the value of V dash, as I said, you can find the charge on any capacitor, and once you are able to find the charge on the capacitor, we can find the charge on each plates, right? Each plate or like each surface of this, whatever the conductors that they have given. Okay, so I hope so like all these concepts make sense for you. Okay, so because you can see there is like very good connection between all the questions that we have discussed or that I have taken up now. So already that this video is becoming so long. Okay, so I am not discussing this. Maybe in some other video I'll try to discuss this question again, but you guys can take, okay, you guys can try. It's an HC Verma question. So with the concepts that I have taught till now, okay, so if you just go back and practice all the things and note down all the note points, whatever I have told, easily you can tackle any question that is based on what? Parallel plate capacitors, when they are grounded, when they are connected, okay, all this stuff, how the charge distribution will be there or how the charge sharing will be done, how to find equivalent capacitors, okay, equivalent capacitance for these type of conditions. So all these things, no, you can easily find, right? So I hope this concept makes sense now. Okay, and just go back like to start and try to note down all the points carefully. And so like everywhere, whenever the key points are there where students will what, do mistakes, so I try to explain that concept very clearly initially itself. Okay, so like this you can see, so this is where the misconception arises. They don't know what is the value of q, they don't know what is the value of v over here, and they don't like, so this is of like, these are the small areas no where students won't be having clarity, and because of this they'll feel that the subject is difficult. But once you have clarity in these type of small key points and key definitions, okay, like yesterday that like in recent class I have taught one more important concept about thermodynamics. Sorry, again I was telling thermodynamics, my bad. Yeah, it's like buoyancy force, right? So fluid statics, I discussed the concept on fluid statics. Again there, like people will often get confused about like how the buoyancy force work and what is the buoyancy force. And I'm going to come up with one more important question based on the buoyancy force, that will be very interesting. Okay, it's a question based on like mixed concepts of rotation motion and buoyancy force. That will be very interesting. And see, so like often, so you'll feel the subject is difficult only because, okay, only because, so you'll be having misconceptions, or you won't be having 100% clarity in the definitions or the key points that are required to tackle that question. So but once you have clarity in the key points, obviously you can tackle the questions very easily. Okay, so as a this is the phrase that I'll always use in front of my students in my class. That is like, for physics, or I believe quality is more important than what quantity. Instead of solving some 100 questions without any clarity or without understanding the concept, instead of that, even if you solve less number of questions, okay, ensure that you do it like in a quality manner. That means you understand each and every step, like what is happening and how the things are working, then only you'll be able to replicate in the exam, right? So that's the like complete agenda, like complete motive of this YouTube channel also, whatever I'm doing. So I like, if you want me to solve these questions, right, so I can easily solve within like what short amount of time. But I wanted to explain the concepts, and I wanted to like teach you, okay, like the approach, how to like simplify the things and all this stuff. So yeah, so practice well. Okay, so if, like I'll come up with more videos on different chapters. I hope all these things is pretty much helpful for you. Yeah, thank you guys, bye bye.